and carbon. Now, in the last question, it said list them in order of increasing covalent character. So, who would be the least covalent? Starting with the biggest number, because you're going from 4 to 0. So, you would start with KBr, then HF, SiCl, SO. Now, you could alter this. This doesn't matter because you got two that have the same number, right? So you could either have CH or you could have HI. Either one of those are interchangeable. And then end with SES. Any issues with this page? Okay. Now, the last page of our homework is not on the quiz. Okay? With the Lewis structures.
So what's on the quiz? Just electronegativity. Yeah.
Yes, stuff that we just did and some vocabulary stuff that we talked about yesterday, like bond length, bond energy, molecule, diatomic molecule, any of that kind of stuff. All right. Check your homework answers for those of you who don't. Now, number 6 is what, I think it was Andy who asked me this. How to draw number 6? Because there are more than 8 electrons on sulfur. We're going to talk about this today. It's called an expanded octet. It has more than 8 electrons on sulfur, and it's perfectly legal. Mark Ashanti here before I forget.
Wait, why did they have brackets around the first two?
On what?
1 and...
Because it's a what? Anybody remember why I have brackets around 5 and 6? 4 and 5? They're polyatomic ions. They have extra electrons in them.
Wait, why did they have extra?
The negatives on. Okay, I have a question. What does it do about
Remember I told you I was going to teach you 2 exceptions?
No.
When we did hydrogen, I told you I was going to teach 2. That's the second one.
I'm not talking about 4. I mean like 1.
Oh, 6 isn't really 1. Y'all will recognize that without difficulty. More
oh,
on
that's 4 and 5.
I didn't think you could do more than 4 around the 6.
All right, Ashanti is fixed. Yeah, and number 3, boron is the second exception that I'm going to make y'all learn. It's the only 2 that I'm going to make you know. Hydrogen and boron. All right, boron is the second exception. Okay, this one, all right, only has 6 electrons. It doesn't have 8. Those are the only 2 exceptions that I'm going to make you know. There are others, but I'm only going to make y'all know those 2. Now, the expanded octets, there are plenty of those, but you'll recognize those without difficulty. That was what? Bond type. Okay. Now, in answer to Tomas's 4 and 5, in case anybody else wanted to know why they had brackets.
1 and 3.
1 and 3?
No. I thought the brackets were around 1 and 3. That's why I was confused. I didn't see the 1 and 5.
I thought they only had brackets around them if they had a number at the top.
They do.
But none of them do. 4 and 5.
Here, let me change to black. I didn't use black on this.
But 1 does. I get it. But 1 and 2 don't. Oh, there are brackets. This one.
Yeah.
But number 6, then why does it have more than 8?
Because it just has more than 8. We're going to talk about expanded octets today and molecules that have more than 8 electrons on their central atom. There are lots of geometries I can teach that have more than 8 electrons on the central atom. I'm only going to make you learn 2. Just as y'all are in an honors class. But there are others we could do. Does that help with which questions or which answers?
Yes.
Okay.
Are we moving on?
Say what? No, sulfur has 6. So it has 6 lines. So technically, sulfur has how many electrons on sulfur? It has 6 lines. It has 12 instead of 8.
But that's like an exception.
Mm-hmm. You won't have any trouble with the exceptions.
Does sulfur can have more?
Yeah.
Okay, gotcha. Thank you.
All right. Like that. I have some people besides Celia and Stephanie. Yeah, besides Celia and Stephanie yesterday. Yeah.
On number 10, would it be wrong if we put
What is it? You got some comments?
4 lines?
On number 10, would it be wrong if you put 4 lines where?
Instead of the dots over and under S.
Yes. You cannot have 4 lines.
You can't have
About.
No, I mean like one extra one for each.
Like 2 lines, yeah, 2 lines, others, yeah. No.
Yep.
Well, you're gonna,
It says you never.
you're gonna have to have
Yeah,
dots on CL.
She
It's
says
not
you
gonna
never
go to
start with extra lines. So, you got this?
You said Crocs is not even here. I'm here.
Yep.
So what number 8 and 10, could they be like? Maybe like.
Yes. Now, on number 8, Tiffany asked if we could do number 8 like this and switch your double bond. So you had the double bond here and the single bond on this side for number 8. If you did this instead of this, yes, that's fine. Okay? Because you still, whoops, I'm opening the dots off. All right. This is still the same thing in 8 as this. The only difference is you flip the double bond to the other side. There's nothing wrong with that. Okay? Now, the question about yours with 4 lines. You want to draw it for me so I can see it? Okay? And here's 13 and 14
Can
while.
you go back?
Yeah.
See what I was talking about?
Yeah, but I was going to let you draw what you had for 10.
Oh, yeah. No, I
So-
just-
Here, draw what you had for 10.
Okay. See already.
Uh-huh.
How many dots is that?
I had 6 on each CL.
No, let's do that.
Okay. Now, Tomas had this for number, what number was it? 10. Okay. How many dots are we supposed to have in number 10? How many electrons did y'all add up? Number 8. How many did y'all add up for 10? Y'all are supposed to have 20 electrons. All right. Does he have 20 electrons? 10, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. He's got 20. So we met the first rule. Does everybody have 8?
No.
What's wrong?
CO got
You got two.
10.
This one has 10.
Oh.
This one has 8. This one has 10. That's what the problem is. Okay? You have 2, 4, 6, 8, 10. Okay? That's why this one will work.
That's not what I had. But now I realize I didn't have enough electrons.
Yeah, that's why. Now, if you take these off and you take these off, all right, you have 8 on everybody. Put my dots back that I just erased. All right, so there you have 8 on everybody. Whoops, go back. All right. All right, there you have 8 on everybody. What's the problem with that one? Why is that one not right? Doesn't have enough electrons. All right, everybody has 8. That has 8, 8, 8. But you only have 16 electrons in this structure. And when Tomas added it up, he said there had to be how many? 20. Okay, so you've got 8, but you don't meet the first rule, which was 20, which is why that one won't work. Okay? All right, questions out? Anything else out of the 1 through 14 that you drew wrong? Don't know why you drew it wrong or need help drawing it? Which one? Which one? 7 and 8. All right, 7's PI3 and 8 is ONCL. All right, so PI3. All right. P has how many electrons? And I has how many? There's how many P's? And how many I's? Now, Samaria answered those beautifully. Do you know where she got those numbers?
Yeah.
Okay.
So I got it there.
So we got 26 electrons. So who's the central atom? How many I's?
3.
So 3 I's drawn around it. Now, a lot of you guys asked me about PL, or people in third periods have stopped by and asked me as well. Where's PL up there on the periodic table? If you can't find PL on some homework sheet, what should that tell you? It's not PL on the periodic table. Break it apart and look for different letters. PL does not exist, okay? So, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26. Oop, that was 24. Can't count. 24. So I need 26. So there will be 26. Now, when I draw all that in, does everybody have 8? Darlene's nodding yes. Stephanie's nodding yes. So once I get there and everybody has 8, do I need to double or triple bond it? No. So I'm done. Now, when I do ONCL, all right, I've got, everybody has 1. So 6, 5, 7, for a grand total of how many? 18. Okay. Now, for finding my central atom this time, everybody has 1. So who am I going to pick for my central atom if they all have 1? Who's farthest to the left? So N's going in the middle. Now, like I said yesterday, I tend to draw them in a straight line. You don't have to. You can put 1 on top, 1 on the bottom, in an L shape. Doesn't matter to me. I just tend to draw them in a straight line. Okay? We need 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Does everybody have 8?
No.
It's real easy to quickly go, yep.
No, it doesn't.
Double check. Because as soon as you say yes and you did it wrong, it's likely to screw up not only your geometry, but your polarity for the next part of our lesson today and tomorrow. All right? 2, 4, 6, 8. 2, 4, 6, 8. These two are good. They both have 8. Does this one have 8?
No.
It's got 6. You got to help this one. This one has 8. Help this one. Doesn't matter if you help from the top or the bottom. Choice is yours. Take those, put them in the middle. Okay? Questions? Anybody? Anything else on the homework that's bothering you? No? Fabulous. You need your electronegativity sheet and a writing utensil to do your quiz. This is not on the quiz. Huh? What happened to yours?
I don't know.
What do you mean you don't know? Thank you for throwing your stuff away.
There's like she was saying like oh, I mean, what's the last But I mean, there's something very right to the last.
All right, did everybody get a paper? Now, if you want to abbreviate it, at the top, you may. I will stand for ionic, use a capital I. PC, polar covalent. NPC, non-polar covalent, and you can put M for metallic. I must be able to read your handwriting. You hear me? Oh, and when you write them in increasing covalent character, make sure you write the compound names. Do not write A, B, C, D, and do things like B, D, E, C for increasing order. Write the names of the compounds. So, Leah, did I give you the quiz? I didn't, did I? I didn't mean to. Bring it back. I meant not to give it to you or Stephanie. I know I skipped Stephanie, and I didn't mean to give it to you. Because you don't know how to answer the bottom three. How many of you are still working? Okay.
Who wants to start from least to great? Thought it was high.
Depends on whether I ask for increasing ionic character, increasing covalent character. Okay, you're working now. Hold on, please. How about now? That's a yes. All right, let's spread this forward. All right, for those of you who like titles, title this geometry. Now, geometry is the short name for valence, shell, electron, pair, repulsion theory. All right, or VSEPR for short. All right, valence, shell. What's valence mean? Outer shell. Electron, pair, repulsion theory. Now, valence shell means outer shell. What do we know electron's charge is? Negative. If you have two negative charges coming near each other, next to each other, or near one another, what do they do? What do two negatives do? Okay, I know y'all aren't in physical science, so this is not something I teach in there. Think back to middle school. If you have two, a positive and negative, they do what to each other?
That's right.
All right. Woo!
We think of this like it's man.
I know. Y'all are.
It is that.
It is not.
It's
A
geometry.
positive and a negative do what? They attract. All right. A negative and a negative have the same charge, so they repel each other in science class. Okay. A lot of y'all are thinking math class, which is why I was losing you. Okay. So electrons both have negative charges. So if electrons all have negative charges, what do they do when they get near each other? They repel each other. What does the word repel mean? Y'all know what repel means? Because I just sort of assume y'all know these things, and I'm making incorrect assumptions today. Okay, so what does repel mean? They push apart, okay? So if Sophie's a negative charge and I'm a negative charge, as I near Sophie, what happens? We will push apart. Sophie will push me away, and I will push Sophie away. We can't get near one another, okay? Think of us as magnets. You guys have all played with magnets in your house, a science class, somewhere. If you take two magnets and they're a north and a south, what happens when you put a north and a south together? They stick. What happens if you take a north and a north and try to put them together? Darlene's shaking her head. What happens, Darlene? They push away. They won't stick, right? Same thing happens with electrons. If you take one electron and another electron and you try to get them near one another, will they stick? No, they push apart. They don't like each other. Okay? It's like oil and water. They don't want to be near one another. Or sort of like Jade and Xavier. All right? Don't like each other. Don't want to be near one another. They push away constantly, only without the bickering. So, how does that explain geometries for us? Now, these atoms arrange themselves based on these electrons. They repel each other. So they arrange themselves so they're as far apart as possible. Now, due to atoms' arrangements, each atom can be identified by geometry. So if Sophie's over there and I'm over here, we have a certain geometry. But let's say that Eduardo and Xavier are in the mix, and there are now 4 of us. We have to arrange ourselves in a different geometry so all 4 of us can be far apart. Okay? These geometries are determined where the atoms and the lone pairs of electrons are at. Because if Sophie and I are an atom, and Xavier and Eduardo are lone pairs, are all the electrons going to work the same way? You would think yes. But believe it or not, lone pairs are different than regular atoms. Lone pairs actually hate each other more than regular atoms. They're like the meaner of the electrons. They're the more powerful electrons. So, to determine a geometry, we have to know 2 things. These are the pieces you're going to have to learn to know the geometries. Okay? So, to determine a geometry, there's 2 things we've got to know. The number of atoms on the central atom and the number of lone pairs on the central atom. If we can learn or keep track of those 2 things, we can find the geometry. We don't have to know all the lone pairs. We only have to know the lone pairs where? On the central atom. Everything is based on the central atom. Based on the number of atoms on the central atom and the number of lone pairs on the central atom.
I don't like these notes.
I'm sorry.
Let me take home.
It's the only page of it. Right now for geometries. If we get to polarity, there's another page. Jay, you need to put that on my desk. I'm pretty good at babysitting the phone. All right, everybody caught up? Who said no? You said no, Marissa? Yeah. Okay? Now, illustrate how this works, you don't have to write this down because I'm going to give it to you in a chart. Okay? I'm going to hand it to you. Suppose we have a molecule like CO2. All right? And this is drawn for you. This is your Lewis structure. You drew it. And I say to you, what's the geometry? All right? The first thing you need to figure out in your Lewis structure is, what's your central atom? Is what? Okay? So your central atom is carbon. How many lone pairs are on the C? What are lone pairs? Did y'all write down your notes yesterday? What do we label as lone pairs? I heard one right answer. They're the dots. Okay? These are lone pairs. Right there. How many are on the central atom? There are none. There are no dots on the central atom. There are no dots on the C, right? There are dots out here on O. There are dots out here on O, but that doesn't determine the geometry. These O's and these electrons don't like these O's and these electrons. So these dots and these dots are trying to get away from one another as far as they possibly can. Okay? What? These electrons. Those dots are electrons.
Yes.
They hate these electrons. So they're going to orient themselves in a geometry to get as far from one another as they can. Sort of like in some of my classes when children can't behave, I try to move them as far from one another as they can. Truthfully, I should probably put you and Jade a little further apart than y'all are. Okay? But I don't want to rearrange my entire classroom. Okay? So these electrons don't like those electrons. So in the geometry, they're trying to be as far from one another as they could possibly get. Okay? Now, second thing, how many atoms are on the C? This is the central atom. So how many O's do we see?
2.
1, 2, right? So that is how we determine our geometry. We have 2 atoms. We have no lone pairs. So think math class. Its name comes from what it looks like. What would this be if we connected them? Don't think about that. So its geometry is linear. Okay? The reason I drew that is you've got to know some bond angles. What's the bond angle between here and here? Think geometry class. It's 180 degrees. Okay? Questions? Now, here are the ones you have to know. Oh, shoot. And you have to know them by Friday. Which is why I told you I didn't know your quiz would be Thursday or Friday. It will be Friday.
We won't have this on the quiz.
You won't have this on the quiz. Tiffany's is in, you're right.
We have a quiz tomorrow.
No, because your quiz tomorrow will have this, Lewis structures, and polarity. Okay? That's your next quiz. Your next quiz will be in table format. I'll even tell you what it looks like. Quiz will say, let's say it said Lewis. It will say CO2. It will say geometry. And it will say polarity. You're going to have to draw the Lewis structure. Tell me if it is geometry. Tell me if it's polar or non-polar. There will be 6 or 7 of them.
And what's a lone pair?
A lone pair of the dots. Okay?
You say geometry.
Yeah, they're yours. Okay?
But if it has dots, okay. How do you know there's a lone pair?
If it's dots. If it's not dots, it's not a lone pair. If it's a straight line, it's not a lone pair.
So if it's anything but a straight.
If it's anything but a straight line, it's a lone pair. Where's mine? So I've got it in front of me. All right. Now, look at the next one on your paper. Okay? It says there is what? No central atom. So if you have something like HCl, okay? Let me draw the one we drew in class yesterday. It was like ICl or something like that. Okay? The end of class when we did some practice, we drew like ICL, and y'all all said, Miss Wall, how do we do this one? And I said there was no central atom, right? Just draw the two letters side by side. If there's no central atom, it's what? What's it say on your paper? It's the linear geometry. Okay? Now, what's the next one? Triangular planar. What do you notice about it? When you look at the way it's drawn, and I drew a lot of X's and Y's here. Okay? It looks like a triangle. That's why I pointed it out that way. Okay? A lot of these are easy to recognize if you look at the shapes. Okay? And I'm pointing them out so hopefully you can memorize the names a little easier. The only reason we're walking through this is to help you learn the names a little easier. All right, if you look at it and you connect the dots, all right, it's what shape? It's a triangle. The reason it's called planar is it's flat. It lies flat in the plane of the board. Okay? Now, when you look at this, what do you see on it? Do you see any dots? For Jade here, who asked me about lone pairs, do you see any dots on this X, Jade?
No.
That's why it has 0 lone pairs, okay? Because there's no dots.
On the central atom, it's not a lone pair.
That's right. It's 0 lone pairs. Now, flip to the back side just to illustrate the difference, okay? If you see one that has this, what's that become? What's the difference? What's the difference between this one, which we said was, all right, this one has dots right here, right? So this becomes what? Got a lone pair, so this has 3 and 1 lone pair, and this had 3 and no lone pairs. So this becomes triangular what? Pyramidal. Now you can say triangular pyramidal, or you can sound really smart and say triangular pyramidal. It's pronounced either way.
Or you can say
Are
TV.
the two on the back, are they both supposed to be bent?
Yes. Okay, I'm going to get to them in just a second. All right. Now, you can do that one since we're talking about it. All right, so we just did linear a second ago. All right, which looked like this. All right, and since Jade brought up the bent, suppose you have one like water, which we've drawn a couple times. All right, so you have water with an O and an H, and you've got, let me go this way, like this. Or you can draw it the way Miss Wall always draws it, okay? You know, because I draw and I think in straight lines. Now, both of those are the same thing, right?
Yeah.
They're identical. Tell me this. How many H's does this have?
2.
And how many lone pairs does it have?
2.
Okay, can we agree this is the same thing?
Yes.
Okay. How many O's does this one have?
2.
How many lone pairs does it have? How many lone pairs? None. Okay. So, 2 and 0, 2 and 2. This was linear. This is what? Okay. Now, there's one more you might see. I think I drew it with X's. Change here to that. And let's just do it like that. All right. So, how many atoms are coming off the X? And how many lone pairs are on the X? Pairs. 1 pair. So what geometry is this one? Bent. Now, are you going to have to tell the difference between this bent and that bent? First of all, the answer is no, you're not. Bent is bent. Now, once you know that, what's the difference between linear and the two bends? Linear does not have lone pairs. Does everybody see that? This is just to help you draw some connections, hopefully to make it easier for you to learn the geometries. because you got to know them by Friday. Okay? Normally, I'd make you do it the next day, but I'm trying to be nice in my old age. Okay? Linear, bent. Now, tetrahedral is probably the easiest to do, except for the bond angle. Tetrahedral is the one that has 4. Now, everybody always draws it, and I'm going to draw CH4 because I don't have to draw any lone pairs on that one. Now, when you look at that, what would you all tell me the bond angle is?
Square. Yeah, the shape.
Now, I sucked at geometry. I'll be the first to admit that. I was terrible at it.
Yeah.
Okay? But I know I'm not good at drawing, but even I think I did that pretty good. What'd you say it looked like, Sophie? I thought it did too.
I said that.
Thank you. Oh, there's 2 of you who thought my drawing looked pretty good. Okay? I thought that looked pretty close to 90.
Oh, just between 2 of them?
Right.
Yeah.
I thought.
I think we're asking this overall.
Oh, okay. Oh, I see where y'all were going. Okay. No. That wasn't what I was shooting for. I just talking about the C and the H.
A 90-degree angle is a box.
The symbol for it's not a
Yeah, it's
half
not-
circle, it's a
it's
box.
not-
Yeah. I know that. I was just trying to illustrate that it's, that. But I was just trying to say I was measuring from here to there since Tiffany's like, I was talking about the whole thing. No, I'm just talking about from that C to from that H to the other H. Okay? Now, the reason it's not 90 degrees, though, is because the way we draw this molecule is it's flat, right? It's only using the plane of the board. Are molecules flat?
Yes.
No, molecules are not flat. They use all of the space in front of the board and all of the space behind the board. So this is a tetrahedral molecule, okay? It uses all of that space. Is this a 90-degree angle?
No.
No. Is it greater than or less than 90?
Greater.
It's greater than 90, okay? So the picture I drew on your sheet has C and H drawn like this to try to illustrate that it's flat and in the plane of the board. And this is trying to illustrate that it's 109.5 degrees, which is what it is. And then, And then I drew a darkened, sort of dark triangle to show H. And then I drew a broken line, H back here, right? Did I draw that on your paper? Or am I just thinking I did and I didn't? Okay. This means that it's in front of the board. And this means behind the board.
You guys ever remember that?
Yes, that's why I'm pointing it out. So if I take these 2 off, these 2 lay in the plane of the board. Here, I've got a better one than this. This was kind of thin. Here's my bigger one. I'll draw beads on the floor. A different tetrahedral. All right, so these 2 lie in the plane of the board, and then this one is behind the board, and then this one is in front of the board. But you can see that the bond angle is not what?
90.
It's not 90. It's 109.5. Okay? Now, the last 2 are the 2 that are the what? Expanded octets. Now, what do I mean when I say expanded octets?
They have 1 and 4.
They have more than 4 lines or more than how many electrons?
8. What? 8.
Expanded octets mean more than what? More than 8. Okay? And they're going to be easy to recognize because if you have something like, let's say I write PCl5, for example. How many CLs you go draw around the P? You just go draw 5. Okay? So when you draw 5 CLs, for example, you're going to draw 2 more. Now, the geometry is not hard to keep track of because look at the way this is designed for the name. What shape is that? It's a triangle, so it's called triangular. If I attach this piece, I'm going to borrow Sophie's hand for a second. Hold on to that. All right. What would I get if I connected it here? A pyramid. And if I connected it, one more time, here, I would have another what? Two, and then two pyramids. So that's why it's called triangular, and then bi-pyramidal. Okay? That's where the name comes from. Okay? It has no lone pairs, and then it's got 5 chlorines all the way around it. It will always be 5 if it's triangular bi-pyramidal. Okay? Now, the other one is the expanded octet, and this name is a little different, is octahedral. And everybody always thinks this one should be one that has 8, but it doesn't. I think the example I gave you was X, Y6.
Yes.
All right, so if you have X and you have 6 Y's coming off of it, okay, you don't have anything that has 8. So why do we call it 8 or octahedral? It has to do with quadrants. It has 8 a piece of paper, and we'll go through here in both directions. There's 1, 2, 3, 4 quadrants on top, and there's 1, 2, 3, 4 quadrants on the bottom. So there's 4 on top and 4 on the bottom. There's 8 quadrants, which is why it's octahedral. It doesn't have anything to do with the number of atoms. Okay? Questions about where the names come from. Hopefully that will help it stick a little better. But you've got to use the lone pairs and the number of atoms. Now, find your homework from last night. Okay? So, if you look at number 1, what can you tell me about the first molecule? Does it have a lone pair? So what kind of geometry does it have? It's linear. I want you to do the remaining 13 and tell me the geometry. Okay? Tell me their geometry. Not yet. We're going to get in some polar and non-polar, I hope.
We ain't got enough time.
Yeah, we got enough time. Stop with that. We ain't got time and stuff. Yeah, we do.
We're not gonna finish yet. If we don't finish yet, I don't know what's going.
Too bad. I ain't asked what you want. Somewhere along in here you found or think it's a democracy. It's not a democracy. It's a dictatorship.
It's America.
No, you over here, it's not.
America.
This is Canada.
We're in a different continent.
This is Canada.
I have a question.
Mhm.
We have 2 and hydrogen is the exception.
Doesn't matter.
So we are the essential.
If you just have H and Br, there's no central atom.
I forgot. How do we know if it's supposed to be linear or bent?
Does it have lone pairs on the central atom?
Yes.
It's bent.
Okay, thank you. Why is that?
Anything that has a lone pair on the central atom pushes the atoms down.
That's right. We went, my bad. I'm sorry. Gotcha. So there's no central atom, is it linear?
So what now?
If there's no central atom, it's linear.
That is correct. All right, we done?
Yeah. Yeah, that's what I want.
All right, let's see what you came up with. So if we look at number one, what do you think?
It's linear.
It's linear. There's no central atom. What about number two? Linear. There's no central atom on number two. All right, number three. Triangular planar. There's 3 chlorines, no lone pairs. So triangular planar. Number 4. Same thing. 3 O's, no lone pairs. Triangular planar. Number 5. Bent. 2 O's, 2 lone pairs. 2 and 2. Bent. Number 6. Octahedral. 6 BRs, no lone pairs. Octahedral. Number 7. Triangular who?
Pyramid.
Pyramidal or pyramidal. You got 3 eyes, and what's that right there? It's a lone pair, so that's 3 and 1. So triangular pyramidal. Number 8, bent. Number 9, tetrahedral. You got 4 and no lone pairs. Number 10, bent. 2 chlorines, 2 lone pairs, 2 and 2. Number 11, triangular pyramidal. 3 atoms, 1 lone pair, so 3 and 1. Number 12.
What was that?
Which one? 11 is triangular pyramidal. You've got a chlorine, a hydrogen, and hydrogen, so 3 and 1 lone pair, so triangular pyramidal.
Oh.
12 is what? Bent. Number 13 is tetrahedral, and 14 is linear.
What's 8 linear?
Is 8 linear? 8 is what? It's got a lone pair. 8 has a lone pair, so it's bent.
Is there central atom?
Is what? Yes, in. As long as you have three atoms, it's going to have a central atom. The only time it doesn't have a central atom would be like here, because you have H and Br only. That's not going to have a central atom. That's not going to have a central atom because there's only 2. But if you go here, this has how many? That's got a central atom.
So what is number 9?
Number 9 would be what? What do you think? Yes. Okay. Anybody else? Question. Jay, did that help you with what lone pairs were?
Yeah.
Okay. Anybody else? Question. No? All right. Get rid of that and that. Let me hit save on those lines for all right. There. That way I have it for a third period. All right. All right. For those of you who like titles, title this one polarity. See how far we get. All right. Now we want to figure out if the structures are polar or non-polar. Now, we've already figured out. Okay? We have already figured out if bonds can be ionic, polar covalent, or non-polar covalent. We determine the type of bond using the electronegativity scale. How do we do that? Okay, we subtracted using what? We subtracted using their electronegativity. So we said 4 to 1.7 to 0.3 to 0. Okay? This was for what? The type of bond. Okay? It's going to be very important. Very important when we take the test that you read the question. If it says bond type, then that's what you do. That's not what we're getting ready to do. Okay? We're going to learn a new skill. You already know how to find bond type. At least I hope when I grade those papers on my desk, you do know how to do bond type. And you subtracted the electronegativity and you read that scale correctly. That's my hope. So, if I wanted you to find the bond type of CCl4, you would have looked up C, and it would have been 2.5, and Cl would have been 3.0, and you would have gotten 0.5, and you would have told me the bond was what? Polar covalent. Now, we're going to switch gears. Now we want to look at the entire molecule. And that's supposed to be a small 4, by the way. Okay? Now we want to look at the whole, the whole molecule. I don't know how to make that stop flashing. Well, now, go on the computer. All right? Now we want to look at the whole molecule, not a single bond, but the entire molecule. Okay? What would happen to its polarity if we consider all 4 bonds? Okay? If we have to consider all 4 bonds, what happens to its polarity? Okay? We cannot subtract here and call it a day. Some of you will on the test. Subtract, find an answer, and be done. And you might be right. You might be wrong.
This is on Friday.
No. The quiz for this is on Friday. Test will be next week.
That's what I was saying.
Yes. Largely because I need to finish this tomorrow and I need you to learn the geometries. Now, the easiest way to determine polarity is to do it for non-polar. Okay? Because there are two rules to be nonpolar. If you don't meet both rules to be nonpolar, you're automatically what? You're automatically polar. Okay? You have to meet both rules to be nonpolar. If you do not meet both requirements, you automatically default and you become what kind of molecule? A polar molecule. Is everybody with me on that? Okay, you must meet both. The two requirements are, number one, all the dipoles have to be equal. I will explain what a dipole is. Okay? But in parentheses, I told you, basically the difference in electronegativities must be the same. That's what a dipole is. The difference in electronegativity has to be the same. The second requirement, all the dipoles must be equal, and they must pull in opposite directions. Now, how are we going to know if they're pulling in opposite directions and if they're equal? There are no what? There are no lone pairs. Now, when I say no lone pairs, where do you think I mean those lone pairs are at? On the central atom. So, I've given you shortcuts here to figure out if the dipoles are equal. The electronegativity difference is the same, and there are what? No lone pairs. And the electronegativity difference is the same. I'm going to explain that. Okay? Those are the key differences. If you can follow those two things in the molecules, then you can figure out polar or nonpolar. Okay? How many is? Hopefully nobody robbed the bank again. We wound up locked down for a half hour that last time. I was stuck in ISS forever.
Talking to Miss Moore.
Yes. I will say I was well informed though, because she had a walkie-talkie. All right. Has everyone caught up? All right. So if we look at an example, suppose we have CCl4, which is what I gave you as our example. The two rules. The dipoles, are they the same? Well, the electronegativity difference must be the same. How do we know? Some of you will feel more comfortable looking up the electronegativity difference every time. You can do that if it makes you happy. Okay? But it's a waste of your time. Are all the bonds the same two elements? That's what you need to ask yourself. Are all the bonds the same two elements?
Yes.
The dipoles are equal. You don't need to look up their electronegativities. If the bonds are the same two elements, when you look up all the numbers, what are you going to find about all the numbers? They're the what? They're the same. Now, you can go through the process and look them all up if it makes you happy. But they're all going to be the same if they're the same elements. If they're not the same elements, what do you know? They're different. Okay? So, Are they the same elements? Then step one, or requirement one, we've met. Requirement two, are there any lone pairs on the C? We've met requirement two. What kind of molecule is CCl4? It's nonpolar. Okay? Just to give us a different one.
What was the
What was what?
So how do you-
bonds are the same.
The bonds are the same if all of the elements, all of the bonds are the same if they have the same two elements.
What's the next part?
The next part was rule 2. They have no lone pairs on the central atom.
Okay.
All right, so if I have water, just as a separate one, okay? There, I wrote out the requirements so y'all weren't yelling at me this time. All right, so number 1. Well, are all the bonds the same? So their dipoles are equal. Okay, we meet rule 1. Number 2. Does the central atom have no lone pairs? We default on number 2. What does that tell us about this molecule?
Polar.
You with me?
Yes.
Stop homework. Yes, now, we are only doing, so I don't have to explain this 4 times. We are only doing the chart. Now, those of you who don't know the term piece of paper over, there's a chart on the front and the back. Now, in the middle section, you're telling me drawing the Lewis structure and telling me the geometry. You're filling out the bond type, the geometry,
Thank you, baby.
the Lewis structure, where it says molecule type. Molecule type is what we just did. Tell me if it's polar or non-polar. You with me? I'm not giving you so much homework. What? Yes, all of the charts. For goodness sakes. Oh, my.